to be able to understand the properties of radicals. Um, they're extremely useful. Like I'm building something with wood, and I needed to put this triangle in the exact center of a circle, and I needed a trig, and I needed to know square root properties in order to do it correctly. So it's very very useful to know these kind of things. We want to be able to graph a radical, and that's our mission for today. And essentially, what we're going to do is the guided notes that I gave you are only going to be dealing with an index of 2. But as we get to the last page here, I am going to show you the graphs of an index of 3 or a cubed root. All right. So today is going to be about square roots, graphing square roots, and graphing cube roots. Okay. Now we don't graph cube roots nearly as often as we graph square roots, but I'll show you how to deal with it because the same principles. It's just that, in fact, it's the same principles as what you've been dealing with quadratics when you grabbed absolute value functions. Moving one function here, there. Just it's all about transformations. But what's important though is that we do understand why something looks the way that it does. So what we're going to do is we're going to go ahead and look at this first. F of x equals radical x, and or the square root of x. And what we do is we essentially just plug in a -4 here and see what happens. So if I take the square root of -4 in my calculator, I'm going to get an error. It doesn't exist. So if I went to -4 and I want to graph it, there's no number as an output. It's not there. It's not part of the domain. All right. So -3, same thing. -2, same thing. Can't take the square root of negative numbers, or else you get an I, and an I is ungraphable on the xy plane. All right, he needs his own plane for us to graph them, and that's basically a pre-calc topic. Square root of -1 is I, but we don't graph them. Square root of 0, though, is 0, so I do have 1 point there. All right, square root of 1 is 1. All right, square root of 2 is actually just the square root of 2. It's a decimal. It's like 1.4 something, and so it's like 1.4 something like that. Okay, so it's some 1.4. Square root of 3 is, I don't know, it's like 1.6 or 1.7, so it's a little higher. All right. Now the square root of 4, that's a total estimate though. Use a calculator to figure out whether or not that's correct. I think it's 1.7. Square root of 4, though, that actually is 2. Okay, so what we've got is we've got this hook. All right, the square root function is essentially a hook. It increases, but it doesn't increase like dramatically. All right, it's not like an exponential function, which I think is the next unit. What it does, and if I were to go all the way to 9 here, okay, if I were to enter in a 9, I'd get a 3. So that means I'd have to go off 7, 8, 9, and then it would be like right there. So this thing is like a hook that keeps going. Now what I want you to remember is that this square root pattern this is the parent function. All right, this is the lady here. We have this guy, and this guy. If we keep those major points, okay, we keep this one, and this one. And sometimes this one if we have enough room on our graph. But if we have those 4 points, we can move a radical function anywhere we want. All right. And you will notice that when I move over 1, I go up 1. When I move over 4, I go 2. If I were to move over 9, I actually go 3. Okay. So that is the pattern. That's the pattern for a square root function. All right. And this is the essence of everything that we're going to be doing here. All right. And if you remember everything that we did when we translated quadratic functions, the same transformation rules apply. So, for example, square root of 4 here, and now I'm going to add 3. All right. So here I have a square root function. What happens, do you think, if I just put a +3 at the end? Your intuition probably will serve you well. But unfortunately, I still can't plug in a negative number. Nope. If I do plug in 0, though, I do get the square root of 0 is 0, and 0 plus 3 is actually 3. Okay, square root of 1 is 1, plus 3 is 4. Square root of 2 is some decimal. Square root of 3 is some decimal. Square root of 4 is actually 2, but when I add 3, I get 5. So these two, I'm just going to kind of skip right now because these are the decimals. I just know that it's going to be 3 higher. So really, it's like 4.4, 3, and 4.7. So I'm just adding 3. So what happens is, you probably guess, is that this whole parent function here will actually just lift 3 units. So I went from 0 to 3, and then now, without even a table, I can recreate this pattern here because I have no vertical, this is just a simple vertical lift here. All right. So I have a 1. When I plug in a 1, I get this guy, 4. And then I get a little bit more here. I get a little bit more there. And then when I get to 4, I actually get 5. Okay. So you can see that the parent function actually just did a vertical translation 3 units. Okay. So same principle. So he went up 3 units. Okay. So what do you think is going to happen here if I have radical x a minus 4? And if you want to use the table, go ahead. If you want to pause it right here, investigate it, no problem. But I'm going to go ahead and just, pause it now. Okay. Well, the whole parent function is actually going to drop 4. So everything that we have in this original table will have 4 subtracted from it. And so we end up being at negative 4 here. And then I'm just going to recreate the pattern here because that's the square root function. Okay. All right. So now things have changed a little bit, and I want to show you how this works, because this is one of the weird things about the quadratic transformations, is that when it was inside the parentheses, we noticed that it did the opposite of what we think. This, we think it's supposed to move to the left, but it's actually going to move to the right, and let me prove it to you. Okay, so negative 4 minus 2 is actually negative 6, so I can't take the square root of negative 6. Negative 3, that's going to be negative 5, can't do that. That's going to be a negative 4, can't do that. That's a negative 3, can't do that. 0, I'll get a 0 minus 2. Okay, that still is the square root of negative 2, can't do that. 1 minus 2, that's the square root of negative 1, can't do that. But I can do 2 minus 2. And the square root of 0 is actually 0. So when I get to 2, I'm okay. Now notice what happens then. When x is 2, y is 0. So you can see right there that this is actually not a shift to the left, right? It's a shift to the right. And so this parent function here, right here, will now move 2 units to the right, even though we are actually subtracting. All right. So if I plugged in a 3, okay, 3 minus 2 is 1. Square root of 1 is 1. So notice that the same pattern is happening. It's just the whole hook shape is essentially rigidly staying the way that it is. It's just moving to the left. I'm sorry, right. And so we go here, and then here, here, and then finally here. Okay. So pretty basic, transformation. Let's go here. We're going to move to the next page here, and you can probably guess that, yes, we're going to move that basic transformation without even using this table. I'm going to go ahead and just plot it. He's going to go 4 units to the right. He will go over 1, up 1. And when I go over 1, 2, 3, when I go over these guys go up a little bit, but I need to go over 1 more to get to that next solid point. Okay. So, be wary of that. You only have these 4 points to do a nice quick transformation. All right. And that's really the only thing that the SAT would kind of test you on, is being able to identify where those points are actually going to be. All right. You don't have to worry about the decimals here. You can get to the heart of what it looks like. All right. Now here's a plus 4. So if we were to fill out this table here, we would actually move that hook shape, would go to the left 4 units. So it moves here. Okay. Our pattern is it starts at the x-axis at 0. Then when I move over 1, he goes up 1. When I move over 4, he goes up 2. And when I move over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, he will go up 3. Okay, so these distances here, I'm essentially taking square roots. All right, we've got that shape. Now here's where we have to be more careful, and this requires a lot more thoughtfulness. All right. So still can't take square roots. Can take the square root of 0, so that's 0. Okay, so I have 1, 1. Now we're actually going to go through and we're going to look at the domain of each of these real quick because there's a couple of homework questions associated with that. Now what happens when I throw in a 1? Okay, let's say now I take the square root of 1. So the square root of 1 is 1. Then I have a multiplier there, and it multiplies it by 3. So when I moved over 1, it should have been here, but because I have a multiplier effect, I'm actually going to multiply that 1 by 3. 1, 2, 3, and that's 3. Okay. Now, if I went all the way to 4, I should only go up 2, but because I have a multiplier effect, it actually, that 2 is going to be multiplied by 3, so that means I'm going to go up 6. Okay, so you can see that the hook now has actually stretched towards the y-axis as a multiplier. Okay, now this guy could have moved to the right or left at all, but notice then that this right here is the pattern that you should look for. This value right here is going to be this value here all the time. All right, and then when we move over to here, that should have been an upward movement of 2, but because of this multiplier of 3, he will go up 6 instead of just 2. All right, so that was 6, and you can see how it definitely changes the graph. All right, now you can probably imagine what happens when you have 1/4, and it's the same thing, no negative values, it's still 0, so I have 0. But now when I have 1, if I plugged in a 1, I don't know why I put parentheses there. All right, but 1, square root of 1 is 1, times 1/4 is 1/4, so this goes very small, right there, a quarter. Now, if I plug in a 2, oops, 2 is, it doesn't help. Square root of 2 it's a radical. I can take the square root of 4, though, so let's plug in a 4. Square root of 4 is 2, and so when I plug in a 4, I get 1/4 times 2, which is actually 1/2. So when I plug in a 4, I get 1/2. So this is a very, very small, very large compression towards the x-axis when it's a fraction. So this is definitely good enough for us to graph. Okay. All right, and that's what that does. So look out for those. Your homework has has 9 questions in the Math Excel. So it's not too much, but be very careful. And of course, you can redo it anytime you need. Okay, so now we have a negative sign in front, and we're used to dealing with negative signs because what it did to the actual quadratics. All right, so with that negative sign, it looks like we have a shift to the right too, but then this means that I'm going to reflect it. I'm not moving down. All right, I'm not moving down. This is a reflection on x-axis. Okay, because as soon as the number was positive, if I multiply it at the end, it's going to make him all of a sudden negative. So he just flips below the x-axis. And so what I'm going to do is I'm going to make my parent function a dotted line here. He's going to move over to the right 2. Okay, move over 4, he goes up 2. Okay, that's the movement to the right 2. But now in red, I'm going to go ahead and reflect him. Wait, let me think. Yep, okay. So reflect him here, and now he'll be going downwards. All right, so that's his final thing. This guy is just the basic parent function, and he's going to be lifted okay, in this context, it doesn't. Okay, so let's do the table. I cannot do a negative sign here. Okay, so when I plug in a 0, though, I do actually get 2. So let's fix that. Okay, so 0, 2. Then when I plug in a 1, I get a negative 1, so that's going to be 1. When I plug in a 2, it gets a decimal. When I plug in a 4, I'm actually going to get 0. Okay. So the point of this is, what you want to make sure that you do is, the order is very important. Do I reflect on the x-axis first and then lift it, or do I lift it and then reflect on the x-axis? That's super huge. Now you got to think of the order of operations. Are you supposed to multiply or add first? Correct. You're supposed to multiply first. So if we multiply first, that means that we have to reflect first. Then we will actually lift it up. And so that would be a very different situation if we added it first and then reflected. It would look very different. And so make sure that you do the reflection first. Okay, so here's my parent function. Okay, this is the normal. That's the normal square root. I'm going to reflect her first. So she's now going to go here, here, here. Okay, but then now she's going to go up 2. So 1, 2. So now in red, this guy is the one that gets reflected. I'm not reflected, but lifted. So here, up 2, and up 2. Okay, and you can see that that's exactly what our table has. Okay, that's exactly what our table has. Okay, now this is pretty much the essence of what your homework is about for 1 through 9. It's just that I want you to now be able to handle a cubed root. Okay, so I'm going to do that real quick. In fact, actually, let me save that for the next video. I think I'm probably running in about 10 minutes. Okay, and in fact, we won't actually do, yeah, we can write that out real quick. But then that last page in these guided notes will actually be cubed root, and I'm going to go ahead and take care of that. All right.